Hello, my name is Michael Alice, and today I'll be describing how to draw contour plots by hand. And over here I have a graph of borderless, a shape of the function x squared minus y squared. I just kind of made it by hand, so it's not a perfect to the design, but it's just here to have a visual representation of what the shape would essentially look like. Now, we have this function here, z equals x squared minus y squared, and we know that z squared is a function of x and y. And we can also say that we can also make it so that z is equal to c. So in order to get the contour graph of this shape, we need to be able to set one of these variables to a constant, such as z is already solved here, so it makes it pretty easy to make z equal to c as a constant. And so that in the z plane we can make a contour graph of the xy plane when we hold z constant. If we wanted to make a contour graph of the yz plane, we'd hold x constant and equal to c. And then your contour graph would be, anywhere along this, depending on what you set x to be. So, but for right now, we'll be focusing on the z plane, well, the xy plane as a function of z, a function of x and y. So the first graph at the origin should generally look something-ish like this. It's not quite perfect, but it's close enough, I think. And but that's just hoping that we get to that kind of result in the end. But it's important to make sure that the graph that you're making is clear to begin with. So in order to make this clear, we need to plug in what we know is c is equal to x squared minus y squared. Now we could just put in numbers for x and y and see if we can result it in whatever constant we want, which in this case is c equals 0. But if we want, this would take a lot of work and effort, and it would just be a pain to do. So what you can do instead is solve for y and solve, and that would, when you solve for y, you can just plug in one variable instead of having to plug in two, and that saves a lot of time and effort, because as soon as you plug in a value for x, you'll get a y result, which is nice. In this case, we get the fact that y equals x, and that is a result that we get. It's also a result is negative y equals negative x. Both of those ends up being resulting in 0 on this particular function. And so what that would look like in on a graph such as this, it would end up, it would be y equals x. And the same for the negative sense, negative y equals negative x. That's too thick. And this is essentially c equals 0. And to label that, it would be best to just draw a line from it and label it with your c value. And this would be along in a neat line, along with lines drawing to each of the curves that we make. In this case, they're just lines. You would write your c values in that order. So for c equals, let's see, for c equals 1, we would plug in 1 again, but this time it wouldn't just end up in a clean result like this. When we solve it, it'll end up looking like this. Y equals x squared minus 1. Now, to solve this isn't very clean, but we can get approximations. Now, what the easiest one to solve for right now would be for x equals 1. When x equals 1, 1 squared is 1, minus 1 is 0. Square root of 0 is 0. So then y would result in 0, which would be this point right here. And to mark it at the dot, we just kind of scribble something right there. Now the next point, it's not so obvious or clean. When we have x equals 2, it would result in 4 minus 1, it would be 3, square root of 3, which is about 1.73, I believe. And so we know that x, we did that wrong. X equals 2, that's x squared. When x equals 2, y would equal 1.73. When you, the whole idea about careful sketching is that you carefully sketch what you draw. So we know that it's x is the second one, but it's 1.7 or so, which is roughly right about here. So we draw another dot. Now what's interesting about this really is in a contour graph, well, typically it's you get results both positive and negative, but you have to be careful and consider the original function's domain. If you end up in a result in xy coordinate that's outside of the permitted domain, then you won't be able to use it regardless. But I forgot to put in here the positive and negative values. For x, you can have both positive 1 and negative 1, and you get 0 as a result every time. For this, for y, what's interesting is you can get a positive and negative result for the square root of 3 because it's positive and negative out here. I'm not 100% sure about that, but that's how, as I understand it right now. If it's not, I hope I could get some feedback on that so that can be corrected. But since it's positive and negative of the square root, x can be both negative 2 and 2 because it's squared. So we know that from this first thing that we calculated, x equals 1, it can also equal negative 1, y equals 0. So we know that x is also at negative 1, as well as negative 2.7 something or other, and negative 2.7 something or other. And same for over here. Now, what about another point? What if x equals 0? Well, I probably should have started with that since that makes more sense in the long run. When x equals 0, y equals the square root of a negative 1. Oh, right, it's a negative number, you can't have that. So, that won't do. So, last and not least, there's the x. When x is equal to 3, you get 9 minus 1 is 8. Square root of 8 is about 2.83. So, plugging that in, you get at x equals 3, 2.83. Pretty close, but a little bit under here. Both positive and negative, and over here as well. And so you should be, I mean, on a more accurate graph, this should be more clear than this, but you'd find that your results would end up being something of a parabola. And this would be C is equal to 1. Now, what about C equal to negative 1? Well, then the result in this would be, well, you would get the function, end up with the function y is equal to the square root of x squared plus 1 instead of minus 1. That makes things a little more interesting too, because you would end up with, you could have when x, by the way, plus minus, of course, you can have x equal to 0, and then y could equal the square root, positive and negative, of 1, which is about, let me check real quick. Oh yeah, of course, I'm an idiot. The square root of 1 is, of course, 1. And so, when, and plus some positive and negative. So, as that said, when, yes, you would end up with positive and negative y equals 1. For x equals 2, or 1, I mean. When x equals 2, 1, when x equals 1, y would result in 1 squared plus 1 is 1. 2, I mean. So it would end up in square root of 2, which is about, I have to check this, but it's about 1.41. Positive or negative. So, also, the x would also be positive or negative because it's squared in the function. And so, this would result in, when x is 1, y would equal 1.41, which would be about here. Same about here. Right now it's pretty close to there. And on the other side too. And up here. And what about, let's see, x equals to 2 for this over here. So when x equals 2, y would end up with 4 plus 1, the square root of 5, which is about, let's see, square root of 5 is about 2.23, 2.24, 2.24. Positive or negative, of course. So, putting these in at x equals positive or negative 2, y would equal positive or negative 2.24, which is about 2 1/4. And 2.24. I think think I made these ones taller than the bottom ones. So, again, this should also look like a more accurate graph, like a parabola. And you would simply label this again with a line going up to your upper right or wherever you decide to write these in with your C value. C equals -1. Ideally, you would also want it in descending order or ascending order. As long as it's ordered, I'm pretty sure it'd be fine. But yeah, that's basically how you draw a contour graph. And just to show you once more, the at C equals 0, this is the kind of look what we get. We get this basic X shape, and that is what we get at C equals 0. For C equals 1, or anything really above that, you'd end up getting this parabola shape that moves away from the z-axis as your C value grows. And likewise, you also get this other parabola that goes in the other way for z in the negative direction, for C equals -1 and lower. And so that's how to draw contour sketches as well as careful sketches. So yeah, thank you and hope you have a nice day.